I'm Jonathan Tomkin from the University of Illinois. It's often said that the root cause of all our environmental issues is overpopulation. It's certainly true that there are more people around today than there have ever been in the past, and as you can see from this figure, the growth appears to be exponential. And pretty much by definition, an exponential growth curve is not sustainable. So in this short lecture, we'll examine some of our underlying assumptions about population growth.
I'm afraid if we don't do something soon, something dreadful is going to happen to all of us.
Well, I've got to trust somebody around here, that's a cinch. But in order to help you, you've got to help us.
Oh, I'll do anything I can.
Well,
the most common way to express this underlying idea about population damaging the environment is the so-called IPAT equation. In this equation, I stands for the environmental impact, P stands for population, A stands for affluence, and T stands for technology. This formula is a little bit clunky. What exactly does affluence mean? So we'll use a slightly more specified version. In this case, the impact equation refers to sustainability impact is equal to the population multiplied by the consumption per person and the impact per unit of consumption. So now if you actually do the math on this, you'll see that it reduces out and that the impact equals the impact. According to this formulation, if we double the world's population, we double the impact on the environment. Similarly, if consumption doubles, then also we double the impact on the environment. On the other hand, if we design new technologies, for example, vehicles that get higher mileage or energy-saving devices for the home, we can use technology to reduce the amount of impact per unit of consumption. What's wrong with this idea? What's wrong with this formulation? This equation captures a common gut instinct about why increased population is bad for the environment. In this equation, more people always means worse impact, more damage. By stating it, we understand our assumptions, and it turns out we have to be very careful, as the world is not as simple as IPAT. So what's wrong with IPAT? Well, firstly, it doesn't work if we try and extend it into the future, because the equation assumes that all of the terms are independent. That is, population, consumption and technology are unrelated to one another. In reality, this isn't true. If we increase population, we increase our ability to make new transformative technologies. Similarly, if we increase our population, our patterns of consumption change. Here I've got an image of Manhattan, part of New York, and in some ways you could argue that this is one of the greenest places in the United States because the environmental impact per person here is much lower than the average for the country, despite the fact that consumption is actually quite high here. The average person in Manhattan is wealthier than the average person in the United States. So changes in population patterns can also make changes in the impacts we have on the environment. And as we move to a more urbanised world, in some ways, that impact actually goes down. So if we try and look towards the future then, the increased population of the near future will have an unknown impact on the environment. For the math geeks, we would say that P, A and T, the terms in the IPAT equation, are functions that are dependent on each other. And if you think about it, even the I, the impact itself, should influence the other side of the equation. A worse environment means that we will have less people, lower rates of affluence, and different technologies. So we can use this equation when we're thinking about the past, but it's very difficult to use when we apply it to the future. Secondly, too rigorous application of the IPAT equation means that we discount the human experience. Do you like your life? Do the people you know like? Is it worthwhile for you and those you know to experience life? And of course the answer is yes. And this is true all around the world. So one of the things that we should realise then, in of itself, high population is a good thing because there are more people enjoying their lives. How do we make meaningful lives that let people reach their potential? Self-determination requires some amount of consumption. It requires some amount of affluence. So consumption in itself is also a good thing. And this is reflected in many sorts of data. In fact, GDP per person, which is a measure of individual consumption, is a reasonable approximate measure of human development, and it pretty accurately correlates with things like education, human rights, health, welfare, and even happiness of countries. So if we want people to be educated, self-deterministic, happy, then we want people to have the ability to consume. The iPad equation makes us think that consumption and population are always wrong, whereas in reality they may have a negative impact on the environment. In of themselves, they are positive things. And we should also be aware that not all consumption is equal. A lot of the modern goods that we purchase have less impact on the environment than goods we purchased in the past. A good example is books. A third of all books purchased in the United States last year were e-books, just like our sustainability textbook. Another important field is education, and education is having a diminishing impact on the environment. Consider yourself. You're consuming a course, as many other people are, but we're not heating a lecture theatre, you don't have to drive anywhere. The impact is much less than it was in years past. So to summarise, I would say that the iPad equation, although a useful idea and embodies a lot of our thinking, is not very predictive, and we have to be very careful if we think this is how we can look into the future. So we're going to consider the future in the next two sets of lectures where we think about some of the classic ideas about where society is headed.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.